This is Ritesh Srinivasan and welcome to my channel. In this video, let's look at CodeGen from Salesforce Research. So this is an AI program which will write code for you. So I have covered Google Alpha Code some time back. Alpha Code is also a system which can generate solutions for competitive programming problems based on the textual description of the problem, right? Then you also had GitHub Copilot, which is also your AI pair programmer. So basically over here, if you have these text prompts or descriptions, it is able to actually generate the code for you. Okay. So in a similar way, Salesforce researchers have now come with something called as CodeGen. Okay. So how is this different from say Alpha Code or GitHub Copilot? So what they claim over here is that they have come up with something called as conversational AI programming. Okay. So what is conversational AI programming? So they have created a large scale language model called CodeGen, which turns simple English prompts into executable code. You don't write any code yourself. Instead, you describe what the code should do in natural language and the machine writes it for you. For example, they have this example over here, which is about asking CodeGen to solve the two-sum problem. Okay, so here you actually prompt saying that solve the two-sum problem in plain English, and it generates this code over here. Okay, basically it generates a function that solves the problem correctly, right? Now, what about conversational coding over here? Right, what is the conversational aspect? Okay, so if you go a little bit below in this particular article over here, so they have given this example of conversational listing. So here it says solve the two-sum problem, you get an answer, right, or you get the code generated, and then you give another prompt saying that solve the problem using hash map. So here it has to actually back reference and understand that this is a two-sum problem, right? And for that it needs to generate a solution using hash map. Okay, so basically it has to back reference and understand this problem. So this is where they have created this kind of a conversational AI which can help in programming. Okay, so the concept over here is that this is the concept over here, right? A human asks like, I would like to create a red button. The machine says, where do you want to position the button? In the center. What happens if the button is pressed? Right, the machine asks. The human says calculate a measure of center for Bitcoin's price over the last 10 days. Machine asks whether you want mean, median or mode. Human says mean, please show me the code. Okay, the machine shows the code generated. And then the human says that, okay, I want to revise some part of this code, and it generates the code. So that is the conceptual, what you call conversational AI. But what they want is, how have they implemented it practically or the current state? Okay, this is the future. What does the current state look like? The current state is this particular CodeGen language model. Okay. So what are the benefits of such AI models, right? So benefits of such AI models is that even if you are not a programmer, you can write programs. Okay. You can generate programs. Okay. For a programmer, it is about, if you have some understanding of the program, can you actually generate your code quickly? Right, and if you have good knowledge of the programming, then programming language, can you actually specify some further specializations or specifications in your code? Like for example, in this case over here, so the initial solution is actually O of n square, whereas the second solution is in linear time. But for that second solution, you need to understand that this problem can also be solved using hash map, right? Further, they have given in this article what are the advantages of such systems. Okay, what is the societal benefits and impact of such systems? Like, in the future, programming is expected to be more complex, right? What if, future programming becomes so complex that the skills need to create these programs outstrip human capabilities? That is where if you have a pair AI programmer to help you, it increases productivity. Okay. Then about coding, it opens up coding to all. You can use this to teach in education for teaching children, right? Or for your lectures, right? It helps in software professionals, non-software professionals. So the idea is that in general, democratizing programming will reap benefits to the society. Okay. So if you go through this article, a lot more details is given about, what is the concept of programming, what is the current vision, what is the future vision, what is the current state, and they explain other things in this article. I'll put a link to this article in the description of the video. Okay, they have released also this research paper which talks about, what did they do for in this particular language model, right, called CodeGen. So CodeGen has up to 16 billion parameters. It is trained on TPU v4, and they say that it outperforms OpenAI's Codex, which is the model behind the GitHub Copilot. Okay, that is what they claim over here on the particular human eval benchmark. Okay, so how did they develop this particular language model, right? What is the training data they used over here? Okay. So the training data they used is over here is that they looked at data sets like the Pile, the BigQuery, and the Big Python. So these are data sets. For example, the Pile, it has programming language data collected from GitHub repositories with more than 100 stars, and these constitute 7.6% of the data set. So they have used this particular data set. Okay, and the natural language model trained on that is known as CodeGen NL. Then you have BigQuery multilingual dataset, which is Google's publicly available BigQuery dataset. It is a subset of that. It consists of code in multiple programming languages such as C, Python, Ruby, right? So that is what is written over here. And they also have Big Python, which contains a large amount of data in the programming language Python. So they have used these datasets. They have done some pre-processing on these datasets. Okay. Then they have developed these autoregressive transformer models, which uses regular next token prediction language modeling as the learning objective. Okay, so that is what they are using over here, transformer models for predicting the next tokens. So that is what is written over here, and here they have explained how they have done the training and other details over here. But the idea over here is, they have come up with something like they have an example over here of their benchmark which they have created. It is something like this. You have an input, okay, which is like define a list of named elements with values. Okay, there is a template or something over here for where you can give input values, right? So this is given to the model. It generates a solution, right? Now you take that solution over here, and then you have the next prompt which says count the number of zeros in variable elements and store the value into variable zero count. Now this first statement, the solution, and the second statement is concatenated and given to the model. You get a solution, right? And this, whatever is the solution till now plus the previous set of statements and solutions are concatenated and given to the with the next prompt over here, and then given as input. In this way, in a conversational way of giving input to the model and generating output from the model, they actually obtain a solution to your particular problem. Okay, and then you can verify this solution using test cases. So they also created something called as a multi-turn programming benchmark, where each turn consists of an prompt and a generated response. The former can be a template that accepts various inputs like this. Okay, for each problem they provide 5 test cases, each of which includes an input which replaces an input in the prompt before it is fed to the model, and an answer to which output of the generated program is compared in order to evaluate its functional correctness. Okay, so they actually created this particular benchmark. Okay, but the idea of this model is this: it's basically a transformer model which generates the next set of sequences, right, given a sequence as input. Okay, and they have trained it on basically your programming language datasets. Okay, for further details of the model you can look at this particular paper. They are also given some examples over here of what kind of code gets generated over in this particular using this CodeGen language model. Okay, so they have it over here in the abstract in the appendices, not abstract, sorry for that. Okay, so here are some generated samples. So this is a highlighted section indicating the erroneous and successful generation. Okay, generated samples for squared Fibonacci problem. Okay, So left is from CodeGen Mono. This is a 2.7 billion parameters model. So over here they say that right is this particular thing which correctly generates the code, correctly implements the square function. Interestingly, however, it did not use the defined function over here. It did not use the defined square function. What it has done is that it has actually directly squared operation is performed over here. It just calls the Fibonacci function over here. Okay, so if you look at both the codes, what happens over here is that here a Fibonacci number needs to be generated. Given a number, the Fibonacci numbers needs to be generated for that sequence, right? So that is what is this function over here. Basically it returns the Fibonacci of this thing, and here is the square function, right? Square is a direct this thing over here, but here the square function is kind of wrong. It is not this is the nth Fibonacci number. Given any number, find the nth Fibonacci number. That's the function. So that function remains same over here, but the square function is wrong over here, right? And here it doesn't do square. That's why this code is wrong. But this is an example. Okay. So basically, if you give prompts like this, import libraries, implement a function which returns this thing, it generates this code. Okay. Another example of a code which has been generated, which is the compare counts problem. While the prompt asks to count positive and negative numbers, okay, count the number of negative numbers, count the number of positive numbers. This CodeGen Mono, this thing counts the number 1 and -1. It doesn't count in a range basically, right? Because this is an array over here, right, which is given as an input. Okay, so this is an input libraries. It does this. It is the prompt. Assign the list of numbers to a variable named my numbers. It does this. It generates this code. Okay, this model generates this code. Then given this prompt and this history, it generates this function. Given all this history and this prompt, right, it generates this function. Okay, that is the idea over here. Okay, so there are some limitations with respect to the model. It also generates some kind of erroneous outputs as well. Okay, but the whole idea over here is that can you actually generate a computer program using a conversational approach where you are prompting what is the code which needs to be generated by giving description in natural language. Okay, for example, this is a machine learning model over here where you want to do some kind of a linear regression on some samples, right? So what they say is that they have created this multi-turn benchmark, right? And in that benchmark, they have actually have these many problems. So this is also their contribution. So if in the future researchers are working on this, they can also evaluate their output of their models on these problems on this benchmark. Okay, so this is quite an exciting development. Yeah, and it will slowly, they will also integrate this into their product. I'm not sure of their roadmap. They also have released this particular code over here, basically the models over here, and they have also released a Google Colab notebook. Maybe I'll cover this Google Colab notebook in another video. I hope you find this video on the Salesforce CodeGen language model, which can write code for you, useful for you. If you like the video, please like, share, subscribe to the channel. See you in another video. Happy learning.